Here circuit has been given and we are told to find the current through the resistor of value 1 ohm and the potential difference between the points B and E. Here we will take help of KIRCHHOFF'S current law and KIRCHHOFF'S voltage law to solve this problem. According to KIRCHHOFF'S voltage law, the algebraic sum of all voltages, both potential drops and electromotive forces, around any closed loop in a circuit is exactly 0. So to solve this problem, first we take the current in arm AB as I and current in arm BC as I1. If we apply KIRCHHOFF'S current law at point B, we can clearly see that current in arm BE will be equal to I minus I1. Now we will apply KIRCHHOFF's voltage law in closed loop ABEFA and BCDEB. Applying KIRCHHOFF'S voltage law in closed loop ABEFA. Here we are going in clockwise direction and we are taking the voltage drops or potential drops as negative and voltage gain as positive. So along the closed loop ABEFA, applying KIRCHHOFF'S voltage law, we get minus 2I minus 1 I minus I1 plus 2 equal to 0. When we go from point A to point B, that is in the direction of current, there is a potential drop in 2 ohm resistor. Since we are going from a point of higher potential to a point of lower potential, and this potential drop is taken as negative, so we have written is as minus 2I. Similar is the case when we go from point B to point E. We are going in the direction of current, that is we are going from a point of higher potential to a point of lower potential. So the potential drop is taken as negative and we have written it as minus 1 I minus I1. But when we go from point F to point A, we can clearly see that we are going from a point of lower potential to a point of higher potential. So here is gain or rise in voltage, so we have taken it as positive, and since this potential gain is equal to the electromotive force of the cell given, so we have written it as plus 2. Therefore our equation is minus 2y minus 1 into I minus I1 plus 2 equal to 0, or rearranging the term we get minus 3I plus I1 equal to minus 2. When we apply KIRCHHOFF'S voltage law in closed loop BCDEB, we get minus 4I1 minus 3I1 plus 6 plus 1 into I minus I1 equal to 0. Let us first look from point B to point C. Here we are going in a direction which is same as the direction of current, and we are going from a point of higher potential to a point of lower potential, so there is potential drop and we have taken it as negative. Similar is the case when we go from point C to point D. Here also here is also a potential drop and we have taken it as negative and have written as minus 3I1. But when we go from point D to point E, we are going from a point of lower potential to a point of higher potential, so there is a voltage gain and which is equal to the electromotive force of the cell, so we have written it as plus 6. Now when we go from point E to point B, we are going in a direction which is opposite to the direction of the current. That is, we are going from a point of lower potential to a point of higher potential. So there is a potential gain and we have taken it as positive as our convention, so we have written it as plus 1 I minus I1. So our equation for this closed loop BCDEB is minus 4I1 minus 3I1 plus 6 plus 1 I minus I1 equal to 0, or after rearranging we get I minus 8I1 equal to minus 6. After solving equation 1 and 2, we get I equal to 22 by 23 ampere and I1 equal to 20 by 23 ampere. So current through the resistor of value 1 ohm is equal to I minus I1, which gives us 2 by 23 ampere, and potential difference between point B and E, which is VBE, is equal to I minus I1 into 1 ohm, that is 2 by 23 volt.